In the third video, we'll pick up where we left off with the emergency department model and look at using the OptQuest add-in to determine optimal resource allocation. So we'll start with the model we left off with in the previous video, where we have our 4 patient types and they go through the registration, exam, trauma, treatment room, just as they did before, and we had allocated a total cost for a particular configuration. So we have $2,000 for each exam room, $2,500 for each treatment room, $4,000 for each nurse, $12,000 for each doctor, and $250 for each patient waiting hours, and in each patient waiting hour. And in the previous video, we added to that the notion of a patient satisfaction, and we define patient satisfaction as the proportion of patients who spend no more than 30 minutes waiting, and we defined as waiting as any time they're waiting for either a doctor or a nurse resource. And so what we want to do in this video is look at a resource allocation optimization, and our goal is to minimize the cost defined here by our cost function, subject to a set of constraints. First being that we want the satisfaction to be greater than or equal to 0.8. So we want 80% of the patients to be satisfied based on our definition here. In addition, we'll also put some limitations on the capacities of the resources, and we really just do this so that we can reduce the time that it takes to do the optimization, because we have from our preliminary runs that we did in the previous video, we have a general feel for the minimum number of resources, and we also have a good idea of what the maximum might be. So we just put these values in. And so what we'll do is we'll look at how to satisfy or to execute this optimization function using the OptQuest add-in. Now, one thing that we have here is we have this satisfaction that we haven't seen before. And what the satisfaction is in terms of a constraint is it's actually a requirement. So as opposed to the remaining constraints, which you can determine whether or not you meet the constraint based on the input values, the satisfaction can only be determined as an output of the simulation. So satisfaction, this is technically not a constraint. Instead, it's what we call a requirement. So this is the model that we left off with last time in the last video, and you can see that we have the experiment that we defined. And so what we'll do to start out is we will create a new experiment. So I'm going to go to Project Home and click on Create New Experiment, and we can see that we have the same doctor, exam, treatment, trauma, and nurse capacity, the reference properties that we had before. And so I'm going to set the warm-up period as we had it before to 3 days. So we run for 10 days with a 3-day warm-up. Next, I'm going to define 3 responses. I'm going to define our total cost response, which is the metric, the primary metric of interest. So we'll call that total cost. And the response expression is simply total cost value, just as it was before. And we, in addition, will set the objective for our total cost. And so we clearly want to, not maximize, we want to minimize our total cost. Next, we'll add a response for satisfaction. And so our expression for satisfaction is simply satisfaction value. And we can set an objective here. Our objective here is to maximize. And so lastly, I'm going to create a response for average number in system, just so we can make sure that we're not that we have a system that's stable. So this is going to be as it was before, num patients, num patients in system, average. There we go. And so these are just the responses that we had before. So we'll go back to our experiment definition and properties and make sure that total cost is our primary response. So now that we have our initial experiment set up, we'll go to the select add-in and we will select the OptQuest for Simio add-in, and we're fine with that. And as we see, we have the Simio additional properties here for our experiment. And so the only property that I'm going to change here is set the number of replications minimum number to 10 and the maximum number to 30. And so now that we have the basic parameters set, we can go back to our optimization and look at our constraints, or our constraints and our requirement here. And so we need to set the satisfaction to be greater than or equal to 0.8. And so we're going to do that by going to the satisfaction response and simply setting the lower bound to be 0.8. And note again that Simio can only determine the value, or determine whether or not this requirement has been met, after a run. So the run value can't be used to help structure the configuration that OptQuest runs, but it can be used to exclude potential solutions. Nextly, we have our doctors between 2 and 10, our nurses between 2 and 15, exam rooms and treatment rooms between 2 and 10, trauma rooms between 1 and 5, and then this final constraint of the total of doctors and nurses have to be greater than or equal to 6. So if we go back to our response, or back to our model, we can set the doctor capacity. The minimum value we said was 2, the maximum value was 10, and we do want to include it in the optimization. Go over to the nurses. The minimum was 2 and the maximum was 15. Again, we do want to include it in the optimization. The exam was between 2 and 10. The treatment was between 2 and 10. And finally, the trauma capacity is between 1 and 5, as we said here. And now, lastly, we need to add the constraint that's not simply a function, or not simply a single constraint on bounding the input variables. So we will click on Add Constraint, and now we see the new section over here, Constraint 1, and the expression for our constraint is doctor capacity plus nurse capacity, and we'll set the lower bound equal to 6. And so now we have our final constraint where the sum of the doctor and the nurse capacity has to be greater than or equal to 6. So at this point, we can go back to our optimization and make sure we have minimized cost, we have satisfaction constraint or requirement, we have our resource constraints all coded into our experiment, and we can now tell OptQuest we want to go. So we're going to click Run, and of course it asks if we want to continue it. Can it be undone? Of course we do. And now we will just let OptQuest run for a little while and be back when OptQuest finishes. Okay, so OptQuest is now finished, and a couple of things to note. First of all, we can see where the satisfaction requirement wasn't met. OptQuest has deselected those corresponding scenarios. So as I mentioned before, OptQuest has no way of eliminating these from being run, because you can't determine what the value is until you do the run. And so unlike the other constraints on the individual resource capacities and our additional capacity on the doctors and nurses, OptQuest could not eliminate these from being run, but it can illustrate or highlight the fact that they don't meet the requirements. Also note that in this case, Simio, the OptQuest ran for all 100 replications, and so if we look at the experiment properties, this is one of the things that we didn't change. We didn't change the maximum number of scenarios, so OptQuest ran through all of the scenarios that we allowed it to go through. So we can go back and look at our total cost, and then as usual we will sort these in ascending value, and you can go to the top here and we can see that the best solution anyway by average total cost is the 6638 solution. Of course, we don't know whether that's the true optimal even in a probabilistic sense, so we want to do further analysis by using the subset selection. So we will go and select the subset selection, and we can see that for both total cost and satisfaction, subset selection partitioned into the two groups of potentially optimal and non-optimal. Again, when I say optimal, I mean with respect to the experimental conditions. So let's take our OptQuest values and let's deselect everything and just select those that fall within the potentially optimal, or potentially best, I guess I should say, category. And then with these, we will select the select best using KN add-in. And then the final thing we need to do before running is to set the indifference zone. Recall that the indifference zone specifies the smallest meaningful difference in value. And so we look at our total cost values. Remember, these are in thousands of dollars. And so we'll just put the indifference zone at 1. Meaning that if we get a value of 22 or 222 and 223, we would view those as not being different. We'll leave the replication limit at 100, and then we click go and run the second add-in, and we will come back once the add-in is finished running. So now the add-in has run to completion, so we will again sort by an ascending order of total cost. And when we scroll to the top, we can see now the KN has selected the configuration 66638 as being the top configuration amongst those that we tested. And so we can see what we did in this video is we took our previous model where we had defined patient satisfaction and total cost, and we used Simio and the subset selection add-in and the select best using KN add-in to essentially solve this optimization function. Again, recall that when we talk about minimizing the cost or finding the optimal solution, in fact what we found is the best solution given our experimental method. So we limited the number of configurations or scenarios that we had OptQuest do, and there was always the probabilistic nature, and so we can't say that we have the true optimal, but given our testing conditions, we found what we'll call the best solution.